Hi guys, so today we'll be solving this problem called rotate image. Let's solve it. You are given an n cross n 2D matrix representing an image. Rotate the image by 90-degree clockwise. So we've been given a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, and we need to rotate it 90-degree and clockwise. So the 1, 2, 3 becomes when it is rotated 90-degree, so it comes to 1, 2, 3, and then when 4, 5, 6 is rotated clockwise, so it becomes 4, 5, 6 here, and 7, 8, 9 comes here. So this is the 90-degree clockwise rotation of each row. Alright, and we need to do it in place, but first you can do it by the naive approach, that is by making another matrix and storing the first row in the last column, second row in the second last column, and third row in the third last column. So you can do this by making a new matrix and storing it, looping through the matrix and storing as it is in the first row in the last column, and the second row in the second last, and third row in the third last. So here the time complexity would be O of n square, and the space complexity would also be O of n square. But we need to solve this problem in place, which means we need to modify the input 2D matrix directly which has been given to us. So we can do this by, let me just make the matrix again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we can do this by first transposing the matrix. So what do I mean by transpose? Transpose means that first row becomes the first column, the second row becomes the second column, and the third row becomes the third column. So 1, 2, 3, so 1, 2, 3 would come here, then 4, 5, 6 would come here, and 7, 8, 9 would come here. And when we get the transposed matrix, then we can reverse it. So we can reverse each row. Okay, so reversing each row would give us 7, 4, 1, 8, 5, 2, and 9, 6, 3. So when we see, this is the matrix which is rotated 90-degree clockwise, and we can do it in two steps, which is first is transposing the matrix and second is reversing the matrix. Here the time complexity would be O of n square for transpose plus O of n square for reversal. So this would be the time complexity. So basically the time complexity would come down to O of n square, but the space becomes O of 1. Why? Because we are doing this in place. We are not requiring any other new matrix. So this is a better and optimized version of it. So guys, let's code this part. So first we need to transpose the matrix, right? So for that we'll loop through matrix dot size I plus plus, then for int j is equal to 0 and j is less than I, all right, and j plus plus, and we will be swapping, we will be using the C++ swap function to swap a of ij to the a of ji. All right, so every row and every column would be swapped. So every row would be swapped with the column element, and like that we need to traverse through the whole row and column as well. So this would be for transpose the matrix. Then we come to the reverse the matrix part. So in this we will be looping through the rows, all right, and I will be using the C++ inbuilt reverse function to reverse this. or you can maybe, use a two-pointer approach to store the first element and the last element and swap that. All right, we can do that, but I'll be using the C++ reverse function. So for that, okay, matrix, it's called matrix. So matrix of I dot begin, comma, matrix of I dot end. So this will reverse the matrix. So let's run the code to see if everything is working fine. Yeah, that works. Accepted. So I hope you guys understood the problem today. It's a fairly easy one. Do solve it. Thank you.